Hello students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now today we'll be starting with a new topic, sigma notation. We'll be using sigma notation with the series. It is not necessarily that it will be an arithmetic series or a geometric series. It can be any series, but we will be using sigma notation with that series. And what does this sigma notation mean? It is a Greek letter and this symbol stands for some mathematical summation. That's why I'm saying we will be using this in relation to some series. We have a series. In every series, we just add the terms of the series. So that is the mathematical summation. And we will be using the sigma notation as a shorthand for writing those terms of the series. We'll be learning about the sigma notation in detail as we solve the questions based on this topic, sigma notation. So let us first of all start with the first question. It is containing 3 subparts and it is saying write each of the following series in full. This is in a shorthand or concise notation and we have to write the individual terms of the series. Okay. Since it is a series, the terms will be getting added up and we will be having the plus sign in between the terms. Okay. Now coming to the sigma notation part, you see along with the sigma notation we are having this variable r and this is the starting value of the variable and this is the ending value of the variable r. So the starting value is 1 and the ending value is 4 of this series. Hence, it is a finite series because we are having both the starting and the ending values. Okay, it is a finite series and how many terms are there in the series? R value will be increasing in steps of 1. So, what are the values that R can have? 1, 2, 3 and 4. Okay. Therefore, there will be 4 terms of this finite series. And how do we get them? We will be just plugging in the different values of R in this expression and we will be getting the individual terms of the series. And the individual terms will be connected to one another by the plus sign. Okay. So the first value of R is equal to 1. Therefore, the first term of the series will be equal to 2 times 1. In place of R, I am writing 1. And within the parenthesis, it is 1 minus 1. Next, we will be writing the second term, so we have to write this plus sign. Sorry, there will be the parenthesis, but before that, we have to write 2r, that is 2 times 2. And within the parenthesis, it is 2 minus 1. Next, r value is equal to 3. So, it is 2 times 3. R value is equal to 3. So, it is 3 minus 1. Plus 2 times 4, R is equal to 4. And within the parenthesis, 4 minus 1. Okay. So, now we have to just simplify the terms and write them. 2 times 1 is 2 and 1 minus 1 is 0. 2 times 0 is equal to 0. Plus 2 times 2 is 4 and 2 minus 1 is 1. 4 times 1 is 4. plus 2 times 3 is 6 and 3 minus 1 is 2. 6 times 2 is equal to 12. Plus 2 times 4 is 8 and 4 minus 1 is 3. 8 times 3 is 24. So these are the 4 terms of this given series. Okay. We are writing 4 terms. We can write 4 terms. We can write 10 terms as well. There is no need of this sigma notation. But sigma notation is very useful when we have hundreds or thousands of terms of a series. We cannot definitely write the 1000 terms individually. You can imagine how much time will it be taking, how much space will it be taking. So it is better to use this sigma notation to express every term of a given series. Okay. Now coming to the subpart B. Over here we are seeing r is equal to 0. The starting value of r is equal to 0 and the ending value is equal to 5. So now, and you may say that why aren't we adding these? Yes, we may add them. 4 plus 12 will be equal to 16 and 16 plus 4 is equal to 20. 20 plus 20 is equal to 40. So this will be equal to 40. But this is not needed for this question. We do not have to give the sum total of the series. They are asking us to give the series in full. That means we have to give the individual terms of the series. Okay. So only this part is required for this very question. Subpart A, B and C. All of them. Okay. And now coming back to the subpart B. The starting value of r is equal to 0 and the ending value of r is equal to 5. And the values of r will be increasing in steps of 1. So what will be the values that r can have? 0, 1, 2, 3, 4 and 5. That means 6 values. So there will be 6 terms of this finite series. You see, this is not a geometric series. This is not an arithmetic series. It is some type of series. We do not have to classify the series. It is a series. So let us come to this series and see what are the terms. Starting value of r is equal to 0. So it will be minus 1 to the power of 0 times 0 square plus minus 1 to the power of r equal to 1. So, to the power of 1 times 1 square. Next, r is equal to 2. So, minus 1 to the power of 2 times 2 square plus r is equal to 3. Therefore, minus 1 to the power of 3 times 3 square. Okay, I can write one more over here. Minus 1 to the power of 4, r is equal to 4 and times 4 square. Finally, plus minus 1 to the power of 5 times 5 square. Okay. So, now we just simplify the terms and write them. Minus 1 to the power of 0 is 1 times 0 square. So, 1 times 0 is 0. Plus, minus 1 to the power of 1 is minus 1. Times 1 square is 1. Minus 1 times 1 is a minus 1. So, it is a minus 1. Next one is minus 1 whole square is a plus 1 times 2 square is 4. So, it is a plus 4. Next, minus 1 to the power of 3 is minus 1 and 3 square is 9. It is minus 9. Minus 1 to the power of 4 is a plus 1 and 4 square is 16. Plus 16. And minus 1 to the power of 5 is minus 1 and 5 square is 25. This is minus 25. So these are the 6 terms of this series. Okay. We do not have to give them the sum total. Now coming to the subpart C. Over here this is also a finite series and we are seeing the starting value of r is equal to 1 and the ending value of r is equal to 4. So there will be 4 terms of this series. R will be having values of 1, 2, 3 and 4. Okay. And for different values of r, we have to just substitute the value of r in the expression to get the individual terms. But where is r in the expression? We are having only a constant number 5. There is no r in the expression. Then what do we do? Okay, there may not be any r in the expression. But we have to write the expression for every value of r. So when r is equal to 1, we have to write the expression. The expression is equal to 5. Next, r is equal to 2. Again, we write the expression. It is 5. Plus, r is equal to 3. Expression is 5. R is equal to 4. Another 5. Okay. So we are having 4 5s. This is the series. Okay. So this is how we get the individual terms of a series when the series is given in the sigma notation form. Let us go to the next question. The next question says, write each of the following series in sigma notation. This is just the opposite of the previous question. In the previous question, they had given the sigma notation form of the series and they had asked us to give the individual terms. In this question, this is also containing 3 subparts and each of the subparts is containing several terms of the series. These two are, you see, these two are finite series and this one is an infinite series. And they have given the individual terms and we have to express these series in terms of sigma notation. We have to give the shorthand sigma notation to represent these 3 series. Okay. So we start from the very first series, the subpart A. And how do we get the sigma notation? The rule is to get the expression for the nth term, the general term of the series. Okay. So let the general term be represented by un. How do we get this? As soon as we see a series or a sequence, the first thing that comes to our mind is to check whether there is a common difference or not. If we have some square terms, if it is 1, 4, 9, 16 that way, then we can readily understand that this is a series of square terms. But if we do not have any square type of things, first thing that we check is whether we have a common difference between the terms. Let's see whether we are having any common difference. 5 minus 8 is equal to minus 3. 2 minus 5 is minus 3. Minus 1 minus 2 is minus 3 and minus 4 plus 1 is also equal to minus 3. So there is a common difference between the terms. So we can write this as, this is a linear sequence or linear series So, since the common difference is negative 3, I am writing negative 3. Whatever is the common difference, we write that. To that we multiply the term number. This is the nth term I have taken, so I have written the subscript n, and this is the term number, so I am multiplying the common difference negative 3 with this term number n. And then we have to add or subtract some number to get the expression for the general term of this series. Now, what number should we be adding or subtracting? For that, let us take the n value to be equal to 1. N value is equal to 1 means it is representing the first term. So, when n is equal to 1, negative 3 times 1 is negative 3. But the first term value is equal to 8. How do we get the value of 8 from negative 3? Obviously, we have to add 11 because negative 3 positive 11 plus 11 is equal to plus 8. Okay. So, and let us see if it is just for this first term or if it is the same expression for the other terms as well. What happens when n is equal to 2? That means it is the second term. Negative 3 times 2 is equal to negative 6 plus 11 is equal to positive 5. Third term, n is equal to 3. Negative 3 times 3 is equal to negative 9 plus 11 plus 2. Fourth term, n is equal to 4. Negative 3 times 4 is equal to negative 12 plus 11 is equal to negative 1. And for the fifth term, negative 3 times 5 is negative 15 plus 11 is equal to negative 4. So, this is the general term expression for this given series. Now, the last step is to just add the sigma notation. It is sigma and n is the variable. N is having its value changed. So, we write n is equal to, what is the starting value of n? It is n is representing the term number. Obviously, the starting value is 1. So, n is equal to 1. And what is the ending value of n? This is the fifth term. Therefore, the nth value will be 5. So, n is ranging from 1 to 5. Okay. And what is the expression? Negative 3n plus 11. Okay. So, this is the expression, sigma notation expression for the subpart A series. Okay. Coming to the subpart B. Again, let us check the common difference. 10 minus 3 is equal to 7. 21 minus 10 is equal to 11. We don't have any common difference. 36 minus 21 is equal to 15. And 55 minus 36 is equal to 19. We are not having any common difference. But do we have a common difference of these differences? 11 minus 7 is equal to 4. 15 minus 11 is equal to 4. And 19 minus 15 is also equal to 4. This is the second difference. We have seen the first difference is not a constant, but the second difference is a constant. Since the second difference is a constant, this is a quadratic sequence or quadratic series. And what is the expression of the general term of any quadratic series or quadratic sequence? It is un is equal to an square plus bn plus c. Okay. Now, in case you do not know about quadratic sequence and these a, b, c, these are variables and we have to get the values of these variables. For them, we have three equations. I'll be just using the equations, and in future I will be making a video on quadratic and cubic sequences. Over there you will be knowing how to get the values of ABC. How to get the values of ABC, I'll be showing it that over here, but how to get those equations will be explained in that video. Okay. But for this video, I'll be just taking the equations. So, for getting the value of A, the equation is 2A is equal to the second difference. In this case, the second difference, which is a constant, the second difference should be a constant. Only then can we use this formula. Okay. Only then will it be a quadratic sequence or a quadratic series. So, 2A is equal to 4 or A is equal to 2. Next equation that we will be taking is 3A plus B is equal to the first term of the first difference. That is this. And 3A is 3 times 2, 6. So, B is equal to 7 minus 6, which is equal to 1. So, B is equal to 1. And for the C, it is A plus B plus C is equal to the first term of the given series or sequence. So, it is 3. A is equal to 2, B is equal to 1. So, 2 plus 1 is 3 plus C is equal to 3. Therefore, C is equal to 0. So, these are the three variables and we have found the three values, numerical values of the three variables. So, for this series, the quadratic expression for the general term is 2n square plus b is equal to 1, so plus 1n or simple n, and c is equal to 0. Let us check whether we have found the correct formula or not. When n is equal to 1, that is the first term. 1 square is 1 times 2 is 2 plus 1. 2 plus 1 is 3. Second term, n equal to 2. 2 square is 4 times 2 is 8 plus 2, 10. Third term, 3 square is 9, 9 times 2 is 18, 18 plus 3 is 21. And you can check the fourth and the fifth terms also, you will be getting the correct answer. Okay. So, our expression is correct. Now, we are having the last step remaining. It is the sigma notation. So, let me write over here. Sigma notation. In the first value of n is 1 and the ending value, what is there? Ending value of n, how many terms are there? 5. So, it will be 5. Okay. And the expression is 2n square plus n. This is the expression. So, this is the answer for the subpart B. Okay. Coming to the subpart C. This is 0 plus 1 over 3 plus half plus 3 over 5 plus 2 over 3 plus 5 over 7. Do you find any sequence rule? I am seeing 2 1s in the numerator, then 3, then falling down to 2, again rising to 5. What about the denominators? 3 coming down to 2, again to 5, then again to 3, then to 7. But one thing I'm seeing, 3, 5, 7. Yeah, and if we take the alternate things, it is 2. I can take 0 as 0 over 1. That can be taken. But for a sigma notation, if I have to express express the whole series with a single sigma notation, I cannot just separate the terms. I could have done that. I could have taken the terms 0 plus half plus 2 over 3. Then it would have been like this. 0 is 0 over 1 plus 1 over 2 plus 2 over 3. Can you see the sequence, the symmetry? This could have been one of them, because it is an infinite series, so I can just divide this into 2 infinite series. This could have been one of them, and obviously this will be another one. It can be 1 over 3 plus, 3 over 5 plus 5 over 7, and so on. So one way is to separate this single infinite series into 2 infinite series and write the sigma notation for each of these 2 series. That is definitely one of the ways. Or else what can I do? What can be done? Let's check. So, if by any means can we make this as 4 and this as 6? If we can make that, then it will be 3, 4, 5, 6, 7. Okay? And this can be written as 0 over 2 also. Doesn't matter. What is the denominator? So it will be 2, 3, 4, 5, 6, 7. We will be getting a pattern. Okay. So, I'll be multiplying and dividing multiplying the numerator and the denominator by 2 of this one. So it is 2 times 2 and this is also 2 times 2. And I do the same thing for this because I want a 6. So the series is equal to 0 over 2 plus 1 over 3 plus 2 over 4 plus 3 over 5 plus 4 over 6 plus 5 over 7 plus ... Okay? So, now we are finding a pattern. The numerators, they are changing by 1, 0, 1, 2, 3, 4, 5. And denominators, they start from 2, 2, 3, 4, 5, 6, 7. Now, there is definitely a pattern. And for the first term, the numerator is 0 and the denominator is 2. And you see the difference between the numerator and the denominator, that is always equal to 2. 2 minus 0 is 2, 3 minus 1 is 2, 4 minus 2 is 2. So it is maybe thought of as some number minus 1 gives you the numerator and plus 1 gives you the denominator. And what is that sum number? If for this first term, if I take the number as 1, 1 minus 1 is 0 and 1 plus 1 is 2. For this second term, the term number is 2. So 2 minus 1 is 1 and 2 plus 1 is 3. For this third term number is 3. So 3 minus 1 is 2 and 3 plus 1 is 4. Okay. Do you understand the sequence? Term number 1, 1 minus 1, 0, 1 plus 1, 2. Term number 2, 2 minus 1, 1, 2 plus 1, 3. Term number 3, 3 minus 1, 2, 3 plus 1, 4. Term number 4, 4 minus 1, 3, 4 plus 1, 5. This way it continues. Okay. So, this can be then expressed in sigma notation. And of course, since I am saying the term number, so I'll be writing, I can take any variable, I am taking n, and the first value of n is of course equal to 1. But what is the last value, the final value, because it is an infinite series. For an infinite series, the last value, the final value will be equal to infinity. Okay? And it will be n minus 1 over n plus 1. Okay? This is the sigma notation for our subpart C, if we want a single sigma notation, or else you can give these two. Okay. This is the first term. If I want to, in case I want to express this series, then what will I be saying? The first term is I am having the denominator as the term number. You see? So I can write this as n equal to 1 to infinity because it is an infinite sequence, and the term number is the denominator and the numerator is term number minus 1. So this will be the sigma notation for this. Okay. And you will be having the sigma notation for this as over here. What will be the thing? This will be a bit tricky. We have to take the term numbers. So it is n equal to 1 and n will be moving. It will be continuing till infinity. So what can I write as the numerator and what can I write as the denominator when n is equal to 1? If I take the numerator as 2n minus 1, 2 times 1 is 2 minus 1 is 1. And 2 times 1 is 2 plus 1 is 3. So can we write the numerator and the denominator expressions as 2n minus 1 over 2n plus 1? Check. When n is equal to, we have seen it is valid for the first one. When n is equal to 2, 2 times 2 is 4 minus 1 is 3 and 2 times 2 is 4 plus 1 is 5. For the third one, n equal to 3, 2 times 3 is 6 minus 1, 5, 2 times 3 is 6 plus 1, 7. So if you have to express this series, infinite series in form of two sigma notations, then you may use this form. Else, if you have to give it in a single sigma notation form, then you have to use this. Okay. So students, this brings us to the end of this session. We will be having more sessions on this sigma notation. Thank you for watching this video till the end. Please give this video a like in case you found it useful. Please subscribe to my YouTube channel. It will be motivating me to make more math videos which may be helping you in your math classes. Okay? And do not forget to press the bell icon. You will be getting notified as soon as I publish a new video. So bye for now.